here's a lesson about chords. It's also going to be a lesson about central angles and inscribed angles. Let's take a look at what a chord is. A chord is a line segment whose endpoints lie on a circle. See how we have a segment here and it starts here and ends here. It starts on the circle, ends on the circle. Here's a chord. It starts on the circle, ends on the circle. Here's another one. Starts on the circle, ends on the circle. That's what a chord is. Alright, we also have to know about central angles and inscribed angles. Now, a central angle is basically two chords that start on the circle, they go to the center of the circle, and then go back and touch the circle again. It's central, it's in the center, the vertex is right in the middle. That's what a central angle is. An inscribed angle is two chords, but the vertex lies on the circle. So the vertex, you would start on the circle, the vertex would touch the circle somewhere else, and then it goes and touches the circle again. So an inscribed angle, the vertex here touches the circle. Okay, let's look at the rules real quick on of how central angles and inscribed angles work. Look, here's a central angle. It comes to the center. The arc that it makes, see how it makes out this arc, the angle? The arc is going to be equal to the central angle. Now for an inscribed angle, see how it comes down, touches the circle and goes back. An inscribed angle, the angle is going to be half of the arc. See, this is 160 degrees. Half of that is 80. Alright, so let's look at how this works. Let's do a few problems. Here we have a central angle. It's 123. It makes this arc. Central angles and the arc they make are congruent. So this would be 123 degrees. Let's look at another. This says find the measure of the arc that's indicated. So in this case, it's asking me to find CFD. So I start at C and go, oops, let me undo that. Oh, I won't undo it anyway. I'm wanting to start from C and go from to F to D. So it's asking for how much this entire big arc right here is. How would we go about doing that? Well, first off, we're going to have to use these central angles and find out these different values. Watch how we can do this. Here's central angle is 81, so this arc right here is 81. Okay. Here I have a line coming through the circle, so I know that this much of the arc is 180 degrees, so I can take 180 and subtract 135, and I would get 45. So that tells me this one is 45, and if this is 45, then this is 45. Excuse that bell, and this right here is also 45, which makes this angle right here 45. Now look at what all we have. We now know how far it is from here all the way to here, because I know this is 180, so I go 180. I know this is 45, and I know this much is 81. So if I add all those together, I'd get 6 and 16, 17, 4, 21, carry the 2, I'd have 316. So that arc is 316 degrees. That's how you're going to have to use central angles and figure out these things. Let's look at this one. Here we have an inscribed angle. Remember the rule? An inscribed angle, the arc that it makes, in this case right here, is twice as large. So if I just take 42 and multiply it by 2, I'd get 84. So my answer here is 84 degrees. Pretty easy. Let's look at another. Okay, this time it's asking how much is this arc. Well, this one's going to require a little more work. If this is 95, then this big arc it makes, I go 95 times 2, I'd get 190. Now I know that this one's 190. It's asking for here. So what I got to do is go 360 minus 190 minus 75. Alright, if I put that, if I do my math here, 360 minus 190 minus 75, I get 95. So 9, so this is 95 degrees. And that's how we do these things. So here's your extra credit. Show the work for these. You don't have to draw the circles. Show the work on how you came up with it. For 1, I'm wanting to know this arc. For 2, I want to know this angle. And 3, I want to know the measure of angle SPQ. So SPQ, this whole angle right here. That's what I want to know. Good luck. Turn it into Mr. Riddle.